Hello, and welcome to this review session on anything related to physics. So, for today, we'll be reviewing uh, the functions called delta functions. So, in most of our courses in advanced physics, we usually encounter two types of delta functions. The Kronecker delta functions, usually involved in uh, discrete cases or discrete distributions, and the Dirac delta functions when you have continuous distributions. So let's start. So the symbol for a delta function is the delta Greek, the Greek delta uh, variable or symbol, that one. So that's the delta. That's why it's called the delta function, because it has a delta. It's the delta, the Greek delta variable. So it can have two forms. If there's a subscript here, say delta ij, this is what we call the Kronecker delta. And if you have something like it's a function of, if your delta function is a function of some variable, say x, then this is what we call the Dirac delta. Also, there are still other types of delta functions, but we'll just focus on these two, the Kronecker delta and the Dirac delta. So the Kronecker delta is usually appears if you have a discrete distribution, and the Dirac delta appears when you have a continuous distribution. Now, the Dirac delta function, the Kronecker delta function has a value of 1 or 0. 1 if I is equal to j, and 0 if I is not equal to j. And that one. On the other hand, the Dirac delta function has a value of infinity at x is equal to 0 and 0 otherwise. So anywhere except x is not equal to 0, or maybe it's much easier for x not equal to 0 na lang, instead of using the word otherwise, if x is not equal to 0. But actually the Dirac delta function can be generally written as, say, x minus a, where a is some constant, and in this case it's infinity at x is equal to a, and it's 0 at x is not equal to a. So actually, if you plot the Dirac delta function, so for instance, this is the x-axis and this is our delta function, it's a function of x, Dirac delta, and say this is a, then basically it's 0 everywhere except at x is equal to a, where the value is infinity. So this is what a Dirac delta function looks like. So it's just it has an infinite value at only one value of x, the rest 0. Okay. In this case, we cannot plot this because this is not a function. The Kronecker delta is not a function. So, where do you usually find the Kronecker delta and the Dirac delta? So usually, when you have summations, the analog of integration. So the analog of integration is a summation. So when you have summations, for instance, summation of I, say from equal to 1 to infinity of a I, and then you have a, say, delta function I j. So if you encountered a summation like this with a delta, the Kronecker delta function, then you're in luck, because whenever there's a delta function in a summation or a delta function inside an integration, You don't need to sum. You don't need to sum over, or you don't need to integrate anymore. So take note, this delta function has a value of 1 if I is equal to j, and has a value of 0 for I is not equal to j. This means that only one term in the summation will survive. Only the term I is equal to j. So the answer for this will be a j. So only the term I is equal to j will survive. Only one term will survive. So that's what happens if you have a Kronecker delta in your summation. On the other hand, if you have a delta function, for instance, in an integration, say you have f of x, you have a function of x, and then you have a delta function dx. Okay. So similarly, if you have a Dirac delta inside your integral, then you don't need to integrate. So you just need, so the integral of f of x delta function dx is just the value of f at x is equal to 0. So f of 0. Or in general, if you have f of x delta x minus a dx, then the answer of this is f of a. The value of the function at x is equal to a. Here at x is equal to 0. So that's what happens when you have delta functions in your summation and delta functions in your integrals. Your life actually becomes much easier. So don't be afraid of delta function whenever you see one, because delta function is helper. It helps you in your summation. It helps you in your integrations. So that's it for this review session, and I will see you again for lesson 4 of the physics review series. So goodbye and thank you.